You can, so your problem is solved, but I might have a lot of people out there that have a similar problem and they've just never said anything about it.
Or they could have been smarter and they knew how to get around it.
Maybe, although I don't know, because I don't tell people that it's going to say GRE on it. If you happen to find one of yours, then you might know to search for that. But still, that's not a very satisfactory solution. That you have to search and know what to search for. You'd probably find them if you also searched for just CC.
I'm going to quickly grab my GRE book.
Okay.
And I'll be right back.
Okay.
Sorry about that. I'm back.
It's okay. Actually, I really appreciate you letting me know that problem, because I would never have discovered it on my end because it doesn't exist on my end. It only exists for the students trying to find their files, and I had no idea. You're the first person that's ever let me know that, so thank you.
Maybe they're not looking up their videos.
Well, or they're looking at it immediately. In other words, if you look at it, say, the next day, it's going to be in that top 15 list. So you'll be able to find it. But if you wait, it's much more difficult to find. So, where did we leave off? I don't remember anything about a guitar.
I think we stopped
at 5.
Yeah.
Yes. And the way we did 5 was just to pick some numbers. And the reason that's a great way to solve 5 is because you don't have a lot of choices. They're telling you x is a negative integer. So there's not a whole lot of numbers to pick. I can't pick -1/2. I can't pick +1 or +2. I'm stuck with negative integers. So all I have to do is pick a couple, and I'll be able to tell that in some cases A is bigger and in some cases B is bigger. I think is what we discovered, right?
I don't remember doing this one.
Well, let's do it then. Hold on a second. Get it so that. And whenever you're picking integers here, pick a big one and pick a little one.
Okay.
In other words, we're going to try an x of -1, and then we'll maybe try an x of -10.
Okay.
Well, what does that equal to with an x of -1?
Exponent of -1, is that 1/2?
Yes. And what about 3 to the x plus 1?
So negative, would you add -1 plus 1 first?
Correct.
And that gets 0.
Okay, what's 3 to the 0?
I don't know. What is it?
Any number to the 0 power is 1.
Oh, okay.
And I mean any number, including
so
0 to the 0 power is 1. So if I tell you x to the 0 power, I know that's 1 regardless of what x is.
Oh, good to know.
Okay, yeah, for sure. So when I used x equal -1, quantity A is big. Excuse me. Quantity
B is. Right.
Now let's try an x of -10. What does 2 to the -10 become?
That becomes 1/10.
No, it becomes 1 over 2 to the +10. So whenever you have a negative exponent, that's all you do, is you take the reciprocal and make it a positive exponent.
Oh.
Okay?
Okay.
So what would 3 to the x plus 1 be?
So that would be 1 over 3 to the 9th.
Yep. Now, this is a little harder. We went through some examples on how we determine whether 3 to the 9th is bigger or littler than 2 to the 10th.
I don't remember doing that.
Okay, well, let's talk about 2 squared, 2 cubed, 2 to the 4th. That's 4. That's 8. That's 16. If we take 3 squared, 3 to the 3rd, and 3 to the 4th, that's 9. That's 27. That is 81. Which one do you think is the bigger number, 3 to the 9th or 2 to the 10th?
Well, the bigger the denominator is, the smaller the number is.
Correct. First, we have to
So it
figure
would,
out which denominator is bigger. In other words, one step at a time.
so the 3 to whatever power would be bigger than
Is a
2 to
bigger
whatever
number,
power.
because if we compare 3 squared with 2 cubed, 3 squared is bigger. If we compare 3 cubed with 2 to the 4th, 3 cubed is bigger by a bigger amount.
Right.
And so 3 to the 9th is undoubtedly bigger than 2 to the 10th.
Right.
Which makes what? Which
Quantity
number big?
A is bigger.
Aha. So what's the answer?
D.
Always. In other words, once you've come up with some numbers where one is bigger with the first number and the other is bigger with the second number, then you know you can't tell.
Right.
All right. I do not remember doing this one. What's our first step?
Would it be to FOIL the
Correct.
top equation?
Uh-huh. Go ahead. Tell me what you get.
I would get xy
Foil it.
I'm thinking
Just follow the F.
minus 4x.
Okay.
Minus 4x.
Okay.
Plus 3y.
Uh-huh.
Minus 12.
Okay. Which is bigger, xy or minus 12? And all of this is equal to 0. And remember, this has to be true for all x's and all y's.
Right.
So, if they were equal to one another, then this would have to be 0, correct?
Yes.
Okay. If a is bigger than minus 12, then this has to be a positive number. If b is bigger, that would have to be a negative number.
Okay, so why would that be the case? Because I don't understand
Well,
that.
because look what I have circled. What's left over is this.
Right.
So if xy were exactly equal to 12, then what I have circled would have to be exactly equal to 0.
Oh, because xy, if you move the 12 over, it'd be xy equals 12.
Let's do that. Let's do that. Let's move this over to the other side. It'll be easier to think about. If we have xy minus 12 has to be equal to 4x minus 3y, correct? just by solving.
Oh, because you switched it over, you have to switch the signs?
Correct. Yeah, when I move the minus 4x to the right side, I got to add 4x to both sides.
Okay.
And when I get rid of the 3y, I got to subtract 3y.
Okay, makes sense.
So yeah, the way I tend to look at it is if I move something from the left to the right, I just change its sign. That's all I do.
Okay.
All right. Now, so if that is 0, then these two things are equal to one another. Correct?
Right.
Because if xy minus 12 were equal to 0, then xy would be equal to 12.
Correct.
If that is a positive number, then xy is bigger than 12.
Right.
If that's a negative number, then xy is smaller than 12. So my first...
But quantity b is negative 12.
What's that?
Quantity b is negative 12.
Ah, excuse me. Okay. That does matter. No, thank you. Let me start from scratch. I don't think it's going to change the method we use to solve it. It's all it's going to do is change. Well, let's think about this for a second. That is definitely minus 12.
Yes.
So, if I do this, now, if that's 0, they're equal to one another. Correct?
Again, what? I'm not sure.
Well, if that's 0, then I got xy equals 12.
Okay, yes, I understand that.
If 4x plus 3y equals 0, then a equals b. If minus 4x plus 3y is greater than 0, then xy would be less than b. Because I would be subtracting a positive number from xy in order to get 12. So, excuse me, a would have to be greater than b. Go through the logic of it. In other words, if this quantity that I have circled were a positive number, say it's positive 2, that means xy has to be 14. So xy is going to be bigger than 12 if this is a positive number.
Okay.
Okay.
Bigger than negative 12.
No. Wow, that really does throw a monkey wrench into things. Let me think about this. This may be one I have to get back to you. I think I got the right idea, but that negative 12 is throwing me for a loop. Let me think about this for a second. Well, for sure, if that's 0, well, no, then x would be a lot bigger than negative 12.
Could you just say that xy is bigger than negative 12?
No, I don't think so. This is what our equation gave us.
Right.
For sure.
Right.
So at this point, let's say that I don't know how to solve it. Well, the one sure way I can try to solve it is by making up some numbers for x and y.
To see if it equals 12.
good idea. Let's have x equal -3 and y equal 4.
So -12 minus -12 would be -24.
Hold on. I like what
Plus 12 would equal 12.
I like what you're doing. It's correct. So x of -3 and a y of 4 makes them equal.
So then xy equals
No, that's only
-12.
with this condition.
Okay.
The question is, what if I plug in a different x and y? If I get anything other than equal, then I'll know it's D.
Okay.
Right? Because I found an x and a y that makes them equal.
Mm-hmm.
So let's just pick any other xy that multiplies to -12. That's actually a great way to do it.
2 and 6?
Yeah, 2 and -6. Got to multiply to -12. In other words, if these two quantities truly are equal, well then this equation is going to be true whether I use -3 and 4 or whether I use 2 and -6.
Mm-hmm.
Well, what happens when we use 2 and -6? We get -12 minus a +8
Which is
minus 18. Does that equal 12? That's -4. No, it does not.
It does not.
So, in this case, they're not equal.
Correct.
When x was -3 and y was 4, they were equal.
Mm-hmm.
So that tells me that I can't tell.
Right.
In other words, I don't necessarily have to prove one greater than the other and then find another set of numbers where the other is greater than one. If I can find a set of numbers where they're equal and another set of numbers where they are not equal, that's all I need to know.
Okay. That I can understand.
Well, it's a tough problem. There may be an easier way to look at it. I don't know. But there's nothing wrong with that way, picking numbers.
Mm-hmm.
In fact, frequently, I think that is the easiest way to solve some of these, especially the harder ones. Okay. Any ideas?
Okay. So, sorry, I'm reading it now. Use 630 to buy a new guitar. This amount was 15% of his earnings last summer.
What does that mean you can figure out right now?
We can figure out what his earnings were last summer.
Let's do it. That's going to answer the problem really easily. In other words, this is one of the few where we're just going to use the algebraic solution.
Okay.
Okay. So give me an equation that lets me figure out his earnings.
So this might not be the best way to do it, but what I usually do is I would multiply it by 0.15 and then add that amount to 630.
That actually isn't going to give you the correct answer. Go ahead and do that. You got your calculator in front of you?
Let me see. So 630.
And you can get that same answer by just multiplying it by 1.15.
That's 94.5 plus 630. I get 724.50.
Okay. Now, is 630 15% of that number?
It doesn't look like it.
No, not even close. So you can't do it like that. What you have to do is solve it like a regular word problem. Come up with a variable and tell me what the variable is. What does it mean? Here's our variable. What is it going to mean? It's always what we're trying to solve for.
What his earnings were last summer.
Earnings last summer. Okay. Now give me an equation that is true. 15% of his earnings last summer were equal to $630. Correct?
So 15% of X?
Uh-huh. Equals 630. Now solve for X.
Oh, so I divide by 0.15?
Uh-huh.
Oh, okay. Let's try that.
When it's worded like this, all of them are worded a little different, but the goal is to put it into an equation. You can't really do that, though, until you define a variable. So that's why the first step is to always define a variable.
So I get 4,200.
Okay. Now, the amount of his earnings not used to buy the guitar, what is that?
So I would have to subtract 630 from 4.
And you can kind of guess that it's going to be that number right there.
It is.
They are equal.
So equal C.
Uh-huh. And I suppose that there would be many ways that you could solve this without doing it the algebraic way. Let's just look at that for a moment. Let's try a couple of numbers. Nah, you can't even pick numbers because his earnings are an exact number. So there's no variables here.
Right.
And it's only when you have variables and your answer has the same variables that you can pick any number you want for that variable. In other words, if we go back to the previous one, well, X and Y weren't defined. They didn't tell us what they were.
Right.
So this is asking, regardless of what X and Y are, which one of these quantities is bigger. So I have to consider all X's and all Y's, and there's an X, Y in the answer, so I can pick numbers and see if I can solve it that way. But number 7, there aren't any variables.
No. We
can figure out his earnings, and you have to do that first. But the key is 15%. You don't necessarily have to do it the way I did it. You could do it this way. You could say 0.15 times his earnings is equal to 630. You're still going to divide 630 by 0.15 to come up with the answer.
Right.
In other words, you can do it as long as you can get to that step right there. You don't necessarily have to say let X equal his earnings. You can, but what you do have to do is write an equation, because the equation tells you how to solve it. In other words, it tells you how to come up with the earnings. You divide both sides by 0.15.
Right.
All right.
So what I had done was, if 630, I wanted to find out what 15% of 630 was, but that's not what I needed. So.
No.
Okay.
His earnings are much bigger than 630. 15% is just a small portion of his earnings. And that is useful to look at it like that. Because if you'd have come up with an answer of 720, you'd have immediately known that it was wrong.
Right.
His earnings couldn't be 720. Always look at the ballpark check. When you come up with a technique that you're not sure of and you get an answer, well, clearly 630 is not 15% of 720. So go back to the drawing board and try it again. And unfortunately, I don't see being able to do this problem without coming up with earnings. You've got to come up with his exact earnings.
Right.
You've got to be able to take this first paragraph here and figure out his exact earnings. think there's even, I suppose you could play around with little and big. No, you couldn't really. You couldn't pretend his earnings are 100,000 because then that statement's not true. And you couldn't pretend they're just 1,000 because then that statement's not true. So you do have to come up with the exact earnings.
Yeah.
I don't see any way around it for that one. Set S consists of 5 objects. The number of subsets of set S that consist of 1 object.
So I'm guessing that's 5.
That's what I would say. The number of subsets of set S that consist of 4 objects. There's our 5 objects. There's 4 of them.
It would still be 5, wouldn't it?
Well, maybe. A, B, C, E would be another one. What it really is 5 taken 4 at a time. Right?
Uh-huh.
It's that. In other words, if you don't want to list out all 5 of the possible subsets, then this is a nice way to do it. And that's 5 factorial over 1 factorial times 4 factorial. And that is 5. So they are equal.
Mm-hmm.
Now, for some reason, that doesn't seem right to me. I'm wondering, it wouldn't matter whether we do a combination or a permutation, we're still going to get the number 5. However, let's just play with that for a moment. If I can come up with 6, then I'm doing something wrong.
Well,
A, B,
it's not
C,
saying
D.
it's without replacement.
No, here, watch what I'm doing. I think I can come up with 6 pretty quick.
Okay.
A, B, C, E are the only 2 that can start with A, B, C.
Mm-hmm.
And then you have A, B, and then you can go C, E. You can also go A, B.
Wait, that's the same as what you just did.
What's that?
The ABCE is the same. Oh,
No, you're right.
is the second one D or B?
No, you're right. I meant to do A, B, D, E, but then you can also do A, B. E, C is the same as C, E.
Right.
So there is only one that's a A, B, D. No, you can do A, B, D, C. That's the same as that one.
Mm-hmm.
So order does matter here. So I got no other A, B's to do. So I can do A, C, D, E. And I can do A.
Oh, I see what you're saying.
I can do A.
So you're saying it's a permutation?
Yeah. Order matters, but doesn't matter in the formula. 5 permutate 4 or 5 pick 4 is still the number 5. So what I'm discovering is if order matters, and I think it does here, if I'm trying to come up with the number of subsets that have 4 objects in them, A, B, C, D is the same as A, B, D, C.
Right.
So those aren't different. So if I'm trying to come up with subsets of 4, they got to be different. Different 4 letters each time.
Right.
Okay, those 4 letters are A, B, C, D. These are A, B, C, E. That's A, B, D, E, A, C, D, E. And I just can't find the other one. What would the other one be? How about B, C, D, E?
Right.
There's 5.
Right.
Now, the question is, can you come up with a sixth one? So this is at least the same as that. It's either the same
Right.
or it's bigger. And I can't think of a sixth one. Usually in these, this is called a counting problem.
Okay.
Counting. Because you can actually list out everything. Just
Right.
like I did. I listed all 5 of them. And
Mm-hmm.
I can't think of a different one. There's only going to be one of those because that's missing the letter A. If we think about it like that, we can see immediately that they have to be the same. In other words, this is missing the letter E. This is missing the letter D. This is missing the letter C. This is missing the letter B. And this is missing the letter A.
Right.
And that's the only 5. You can only be
Right.
missing one letter. So
Right.
they both have to be 5. But
Right.
officially, it would be 5 pick
choose 4.
1 at a time compared to 5 pick 4 at a time. And those two are the same. That's 5 factorial over 4 factorial. And this is 5 factorial over, n minus p. Or n minus r, which is 4 factorial. So they're both that.
So you're saying I could use either of those formulas?
No, they're not the same, are they? One is 5 and the other, let's see, it's n factorial over n minus r factorial. So this top one would be 1. And that would not work. That would give you much more possibilities. But it's easy to see that there's only 5 of those.
Right.
So I got something wrong here. This is correct. For quantity B, we would be taking 4, we would be picking 4 out of 5. And there are exactly 5 of those. Whereas when we're picking 1 out of 5, for some reason it doesn't come up to the same. It's still,
So wait. You said for the top one, you said it's n factorial over n minus r factorial?
Yeah, that's for permutations.
So would r be 4?
Well, for combinations, it's n minus r factorial times r factorial. So combinations change quite a bit. They add a whole nother number in the denominator.
Right.
So there's always fewer combinations than there are permutations. Now I see. I do see. It's not a permutation. It's a combination.
Yeah, I was wondering about that because permutation means that you could switch the orders.
Well, but obviously
ABDE is different than ABED.
Right, but it's not. When they're talking about sets, that's the same 4 things. It consists of 4 objects. That's all. It didn't say what order they had to be in. But I'm thinking that I'm misinterpreting that. And mainly because of the following. What I do know is that 5C4 is 5. And 5C1 is also 5. And from going through the counting process, it looks like they're both 5.
Right.
So we wouldn't use this anyway, but apparently we need to use the combination and not the permutation, even though clearly order matters. Do you have the answer?
When you're saying order matters, that means that A, B, D, E is not the same as A, B, E, D?
Correct. That would be a different set.
But we're not saying that order matters.
No, and in fact, from the way I read it, it merely has to consist of 4 objects. So it wouldn't seem like ABDE and ABED would be different. That's the same 4 objects.
Right, exactly. That's my understanding too.
To me, that means order matters, but clearly you got to solve it with a C, not a P.
But wait, my understanding when you say order matters is that ABDE is different from ABED.
You're right. You're absolutely right. And since order doesn't matter, we got to use combination, not permutation.
Right.
Yeah, and so this is what we should use. Yeah, I was getting confused by I saw that order matters, and therefore I felt like we had to use P, but it's the other way around, and that's still hard for me to grasp. But probably we should go on rather than spend any more time on this. Maybe I'll have some more thoughts about it next time.
Okay.
We solved the problem without knowing whether to use C or P. We didn't have to have that to solve the problem.
Right.
In other words, all we needed to. Now, it might have been tougher if they'd have said consists of 15 objects.
Yeah.
Now, it's not going to be so easy to do the counting.
No.
Counting out like I did is a lot different with 15 than it is with 5.
Right.
So, but hopefully they'll give you questions like this where you can actually do the counting.
Right.
Which is somewhat time consuming. It's much easier if you know to use C or P, but that in itself is kind of a hard thing to figure out.
So you use P when order matters and C when order doesn't matter?
Correct. And I guess order does not matter here.
Right.
And that is the thing. It's just that when I read that, I thought we should be using P. I don't know why. Order doesn't matter. A, B, C, D is the same as D, C, B, A. Right. So that means order doesn't matter. We should be using C. Okay. I guess it's that clear. I don't know why I was 180 degrees off, but that's fairly clear. If order doesn't matter, you use C. And this is 5 objects chosen 1 at a time. And this is 5 objects chosen 4 at a time. Right. And it turns out both of those numbers are 5, because that's 5 factorial over 4 factorial times 1 factorial. And this is 5 factorial over 4 factorial times 1 factorial. So these two numbers are the same. Tricky.
Interesting.
At least they tricked me. I don't know if everybody would be tricked by that, but it tricked me at first. Okay. This problem here, we have our 2 favorite triangles. We have a 45.
And the 30, 60, 90.
Exactly. From that information, we're going to be able to figure out what that side is.
Okay. Well, because we already have 2.
Right. Once we know that side, then we know this side. And we can also figure out that side. So it's going to be real easy to add that to get AC. Is to add that and that to come up with the length of AC.
Okay.
Okay, let's do it. First of all, we do need to figure out all 3 of these. We need to figure out number 1, and we need to figure out number 2, and we need to figure out number 3. Okay. So let's start with number 1. I'm drawing it as a separate triangle because this is the way I've taught it. There's 60, there's 30. What's the side opposite the 30 equal to?
The opposite, the 30? Oh, is this the square root of something?
No, this is just what I call these unit triangles, these two special triangles. And opposite the smallest angle is always 1. And then opposite the 60 is root 3, and opposite the hypotenuse is 2.
Oh, okay.
Okay, so from this, I can figure out the two unknown sides of this 30-60 triangle. What's the side opposite the 30 equal to?
1.
What's the side opposite the 60-degree angle equal to?
Square root of 3.
And now, what is this side equal to?
Well, you have...
That's a 45-45. In other words, that's 45 also. So if we got square root of 3 opposite the 45, then the opposite this 45 also has to be square root of 3.
Oh.
Now,
no, because, right, they're equal sides.
Yeah. Now add those two together, and do you get a number less than 3, equal to 3, or greater than 3?
Less than 3?
That makes B the bigger quantity. Now,
oh, because we're looking at, okay, so line segment, okay,
yeah.
Right.
Now let's back up a moment.
Now I get it.
Because they made this pretty easy by making this hypotenuse 2. What if that said 4? Now I look over here at my unit triangle, and I call this the unit triangle because all I'm looking for is a relationship between the side opposite the 30, the side opposite the 60, and the hypotenuse.
Okay.
So they happened to give us a 30-60 triangle that had a hypotenuse of 2. That made it real easy. Well, what if
right.
they'd given us a hypotenuse of 4?
Then everything's double.
Exactly. That becomes, let's see, opposite the 60 becomes 2 root 3, and opposite the 30 becomes 2. Now this
right.
becomes 2 root 3, and it changes everything. In other words, now A is bigger.
Right.
But my point is that when you're given a 30-60 triangle, the only thing you have to do is figure out a scale factor.
Okay.
For example, and let's do this because I can't think of anything more important for you. And I got to believe you ran into numerous 30-60 triangles in your test.
Off the top of my head, I can't remember, but I might have.
Okay. Let's make that 5. I have a 30-60 triangle whose hypotenuse is 5. Now tell me what
X is. 3, 4, 5?
No. Tell me what X is and tell me what Y is.
Okay, so...
First of all, what's the scale factor? That's always the first thing you have to do. You get the scale factor by comparing corresponding sides. In other words, this hypotenuse is 5, this one's 2, the scale factor is 5 over 2.
Oh, okay.
So now we multiply 5 over 2 by these numbers to get X is 5 over 2 and Y is 5 over 2 root 3.
Okay.
In other words, no matter what dimension they give you, as long as they tell you it's a 30-60 triangle, you can use this unit triangle over here to solve it.
So every right triangle that has 30s and 60, yes, every 36 and 90 has that?
Has these relationships. They're not always 1, root 3, and 2. Sometimes they're 2 root 3. And
but they're ratios of that.
Exactly. Sometimes they're 10, 10 root 3, and 20. What can get hard, and whether they'll give you this, I probably not, but it's the only ones that are really hard. The thing to remember is the basic one, because you can always work out any right triangle as long as you know the unit one.
Mm-hmm.
Now, let me make it a little tougher, and let me give you a hypotenuse of root 6. Now what? What is x?
I don't know.
Figure out the scale factor. That's always the first step. In the problem they gave us, the scale factor was 1. It was 2 divided by 2.
Mm-hmm.
The problem I gave you when I made it 4, the scale factor was 2.
Right.
When I made it 5, the scale factor was 5 divided by 2. So you always take this one, the bigger one, and divide it by the smaller one. That always gives you the scale factor.
I'm sorry, say that again. Always do the what?
Take the bigger corresponding side, divide it by the smaller, that's your scale factor.
So can you tell me again what that would be? So the biggest
Well,
factor is 2?
Square root of 6 is bigger than 2. So the scale factor is square root of 6 divided by 2. And now we take that scale factor and multiply it by everything.
Okay, see, I would not have known that the square root of 6 is bigger than 2.
Well, what's square root of 4?
2.
What's the square root of 5? Bigger or greater than 2?
I'm guessing bigger.
Got to be. If the number is getting bigger, the square root's getting bigger. But
okay.
Nonetheless, you could have used your calculator to determine that.
Mm-hmm.
In other words, your calculator is going to tell you it's 2.2 or something like that.
Okay.
Doesn't matter. The thing is that the scale factor is square root of 6 divided by 2. And I'm going to take that and multiply it by 1 to get this. That makes that square root of 6 divided by 2. And I'm going to multiply it by root 3 to get square root of 18 divided by 2. So that's the way I solve a triangle that's where one is an integer and the other is a radical.
Uh-huh.
You got to find that scale factor.
Right.
If this was an 8, then the scale factor is 4. It's always this side divided by that side is the scale factor.
Okay.
Now, if you happen to have a scale factor that's less than 2, doesn't matter. It all works. In other words, let's say I gave you a triangle that this was 2/3, and it's a 30-60. Well, clearly this is the smaller triangle, but the scale factor is still 2/3 divided by 2. And I'm going to multiply that scale factor by the number 1. And what do I get? I get 1/3. That's what that side is.
Mm-hmm.
Down here, I get 1/3 times root 3, so I get root 3 over 3. So even if it's a smaller triangle than the other triangle, everything still works. You just have to figure out a scale factor. And it doesn't really matter whether it's greater than 1 or less than 1.
Got it.
Okay. I have a 4 o'clock, Carolyn, so I'm going to have to.
Okay.
But I will talk to you next Friday.
Thank you.
You're welcome.
Okay. Great. Thanks. Bye.